In this lesson today, we're going to talk about the basics of quadratic functions and how to graph them. A quadratic function is a function that can be written in the form y equals ax squared plus bx plus c. At this point in the year, all that we have talked about are linear functions, functions of the form y equals mx plus b. So now we're transitioning over into the world of quadratics. So anytime that you have an equation that looks of the form that you see here, this is going to be called a quadratic. We also know that because the degree of the polynomial that we have here is 2, meaning its highest exponent is 2, we know that we have a quadratic function. So a couple things to know about quadratic functions before we start graphing them. Quadratic functions are going to create this picture called a parabola. If you remember back in linear equations, we always created a line. Now we're going to create this curve, which we call a parabola. Now, there's a couple different things that we need to know about this parabola. And the first thing is that when you have a parabola, it is always going to be cut in half. What I mean by that is it's always going to have this thing called an axis of symmetry, which cuts the parabola completely in half. If you were to fold it over, you would have complete symmetry. And we're going to talk more about this axis of symmetry, but the axis of symmetry is actually an equation. The equation is going to be of the form x equals something. We also have a term called the vertex. The vertex is the point in which the parabola is either, if you're looking at the first curve here, you can see the curve is kind of sloping downwards, and then it changes directions and it starts moving upwards. This is called the vertex point. If we have a parabola like we do in the first one here, you can see that the lowest point on the parabola is the vertex. When it's the lowest point, we call this a minimum point. This will always happen when your a coefficient in your equation, when that a is positive, you're always going to have a minimum value. Likewise, if we look over at the other parabola, we have a vertex that's at the highest point of the parabola. This is called a maximum point. This is going to happen when a is negative. So when you have a negative a, you always know that it's going to be facing downward. In Algebra 1, we only talk about parabolas that are facing upward and facing downward. When you get to Algebra 2, you're going to talk about the parabolas that are facing sideways. So for right now, we're just going to stick to the basics. Okay, let's go ahead and talk about how to graph these quadratics. Okay, so to graph a quadratic function, you can see we have the function here, y equals negative x squared minus 8x minus 15. The first thing I want to do is identify my a, b, and c. And that's pretty easy. I just need to go ahead and grab my coefficients. So I have negative 1 as my a, negative 8 as my b, and negative 15 as my c. So the first thing I want to do when I'm graphing a quadratic is step 1. I want to determine the axis of symmetry. This is going to be the line which cuts the parabola in half. So I'm given a formula. This is the formula for the axis of symmetry. X equals negative b over 2a. So I'm simply going to go ahead and substitute the values into that equation. This equation is not given to you on a formula sheet for Algebra 1, so you will need to commit this one to memory. So you can see that my b in my equation is negative, so I'm going to have negative 8, which we know is going to turn into a positive, divided by 2 times negative 1. All right, that's going to be 8 over negative 2, which is going to simplify to negative 4. So my axis of symmetry is going to be the equation x is equal to negative 4. When you write the axis of symmetry, you always want to write it as an equation. All right, what I'm going to do now is I'm going to go ahead and I'm going to graph that axis of symmetry. So we know that anytime you have an equation where you have an x equals something, if you remember that little trick I showed you with the little v's, x is always going to be a vertical line. So I'm going to have a nice vertical line. I like to just kind of indicate it as a dotted line. But this right here is my axis of symmetry. So that's what's going to cut my parabola in half. Now, step 2, determine the coordinate of the vertex. So as you can see, if we kind of think back to the picture of the parabola on the last slide, we know that the vertex is actually going to be on the axis of symmetry. So we happen to already know our x value. So now we just need to figure out the y value. So if we have an x value of -4, let's go ahead and substitute that into our equation. So I'm going to say that y equals -4 squared minus 8 times -4 and minus 15. If I substitute those values in there, I can simplify that right on my calculator. So I have -16 plus 32 minus 15. And I can simplify that again to 1. Okay, so what have we determined there? Well, we know that our vertex is going to be a coordinate point. That coordinate point is going to be -4 and +1. So let's go ahead and plot that. -4 and +1. That is our vertex point on our quadratic. Now, the question is it a minimum or a maximum vertex? Well, if you look at our A coefficient is a negative number, which means it's going to be facing downward. So this is going to be a maximum point on our parabola. Okay, step 3, determine the other points of the function using a table of values. This is going to be very familiar to you. If you take out your calculator and you go to your y equals button, we're going to simply substitute the equation that you see above into our y equals. So we're going to say -x squared minus 8x minus 15. And if you remember what we did when we graphed linear equations, we're going to go to second graph, which is going to bring up our table of values. At this point, you can construct a table of values if you like, or you can just simply plot them on your coordinate plane. So I'm going to first identify my vertex. You could have identified your vertex right here instead of plugging it into the equation. But what I want to do is I want to take a couple, I want to pick one of those points. I'm going to go ahead and I'm going to start with -5 and 0. So -5, 0 is going to be right here. And what I'm going to do with that coordinate is I'm going to reflect it over the axis of symmetry. If I reflect it over, I'm going to get -3, 0. All right, let's go ahead and choose another point. I'm going to choose -6, -3. And I'm getting these right off my graphing calculator. So -6 and -3. And again, I'm going to go ahead and I'm just going to reflect it over my axis of symmetry. And I'm going to just continue finding some points. How about -7, -8? -7, -8 is going to be right here. I'm going to reflect him over that axis of symmetry. And let's see if I have any more. I don't have any more that I can fit on this given coordinate plane. So at this point, I'm done. Now all I need to do is connect my dots. Just like linear equations, we're going to connect these dots and we're going to have a nice curve with nice arrows at the end. So I'm going to start here at the bottom and I'm going to go up and I'm going to go around my vertex and I'm going to come back down and I'm going to add my arrows onto my parabola. Something to be very careful about when you're looking at this, this area up here on your graph, just make sure that it doesn't look like a V. Because if you remember back in Unit 2, we studied absolute value equations. And absolute value equations look like a V kind of when you graph them. So just be careful. It is definitely going to be a curve on the parabola. Okay. Step 4, the last thing we're going to do here is we're going to pull some information out from a long time ago. We're going to try to determine the domain and the range. And we're going to go ahead and put that in set builder notation. So if I start off with my domain here, I'm going to say x such that, and if you remember, we talked about this a long time ago in Unit 3. We talked about the domain of a parabola is always going to be x such that x exists in the real number system. Now, the range is where things kind of change a little bit. Y such that we have to look at our highest y value, which is our vertex. And we see that that y value is +1. So we're going to say that y exists where y is less than or equal to that highest number 1. And that is our domain and range of our parabola. So I know there's a lot of steps here, but we're going to go ahead and look at this 2 more times. So let's go ahead and look at the next one. Okay. Step one is, actually before step one, we're going to go ahead and figure out what our A, B, and C is. So A is going to be 2, B is going to be negative 12, and C is going to be 16. Okay, now that we have our A, B, and C, let's go ahead and figure out our axis of symmetry. So I'm going to go ahead and substitute that into my equation. So X is equal to, be careful with that negative B, negative 12 divided by 2 times 2. It's going to simplify to 12 divided by 4, which simplifies to 3. All right, so again, my axis of symmetry is an equation. X is equal to 3. Be sure to write x equals 3 and not to leave that part out. Okay, now let's go ahead and determine the coordinate of the vertex. All right, so again, we could find this on our graphing calculator pretty easily, but I always like to know what I'm doing in the calculator, so I'm going to go ahead and actually solve it out. So for this one here, let's go ahead and substitute these numbers in. So we have y equals 2 times 3 squared minus 12 times 3 plus 16. All I did was I substituted that x value into my equation. So now I'm just going to go ahead and simplify it. And truly, you can actually do this right in your calculator. You don't need to actually do this by hand, but let's go ahead and just kind of break it down. So 3 squared is 9 times 2 is 18. And then we're going to subtract negative 30 or minus 36, I'm sorry. And then we're going to add 16 there. Okay, so now that we have that, let's go ahead and just simplify it. 18 minus 36 plus 16, that's going to give us y equals negative 2. Okay, so that means that my vertex is going to be 3, negative 2. All right, now is my vertex a minimum or a maximum? We can see that my A coefficient is positive, which means it's going to be facing upwards, and that is going to give us a minimum vertex. So let's go ahead and create our table of values. Actually, let me go ahead and graph our axis of symmetry first and our vertex. So our axis of symmetry is going to be right about here. And I have 3, negative 2. That's going to be my vertex point. And we know that it's going to be facing upward. Okay. Now I'm going to go over to my calculator. 2x squared minus 12x plus 16 right in the calculator. Second graph to grab your table of values. Okay. Let's take a look here. Let's go ahead and just pick a point. I'm going to choose 1, 6. That looks like a good point. And I'm going to go ahead and reflect it over that axis of symmetry. I always like to put the number of coordinates that are available to put on my graph. So just kind of want to just kind of look at them and see what are my options here. Okay, it looks like I can put 2, 0 on there. I can reflect him over. And that looks like that's it. Okay, so and what I mean by that's it is if I choose another coordinate to put on, it's not going to fit on my coordinate plane. So that's all I really need to put on there. So I'm going to go ahead and I'm going to draw my curve in there. You can see again like we have a minimum point just like we talked about. And it looks good. All right, domain and range. My domain, as always, x such that x exists in the real number system. And my range, y such that y is going to be greater than or equal to that lowest point, which is negative 2. And there we have it. All right, last one for today. This time, I changed it up just slightly. I changed the equation to something that does not have a b coefficient. And you'll see why in a second. So let's go ahead and look at this. Let's go ahead and list our a, b, and c. A is pretty easy. It's going to be 1/2. But b is always going to be the value that stands in front of the x term, which we don't have. So our b is actually going to be 0. And then our c is just going to be the constant of 1. So let's go ahead and plug things into our equation here. X equals, I have negative 0. That's just 0. Times 2 times 1/2. So that's going to give me 0 divided by 1. And we know that 0 divided by anything is going to give us 0. So our axis of symmetry is going to be 0, x equals 0. So what that's going to look like is it's actually going to be right on that y-axis. If you can see my pink pen here. Okay, let's go ahead and determine the coordinate of the vertex. Again, we could do that right in the graphing calculator, but I'm just going to go ahead and plug it in here. Y equals 1/2 times my x value of 0 squared plus 1. As you can see here, 0 squared is 0, and then 0 times anything is going to be 0. So y equals 0 plus 1, and so y is going to equal 1. So that means my vertex is going to be 0, 1. All right. There's going to be the vertex of my graph. And if we ask ourselves, is it going to be a minimum or maximum? Well, we know that's going to be facing upward because A is positive. So that's going to give us a minimum point. All right, let's go ahead and determine the values. I'm just going to go ahead and plug in 1/2 x squared plus 1. And feel free to use the 0.5 instead of 1/2. It doesn't really matter. And second graph. Okay, notice that on your graphing calculator, you have a lot of numbers that are half numbers. Don't use those numbers. You have plenty of coordinates to actually work with here. I'm going to start with -4. So if I choose -4, its corresponding y value is 9. So I'm going to go ahead and plot him. And I'm going to go ahead and reflect him. 1, 2, 3, 4. 1, 2, 3, 4. There it is. Okay. And I'm going to choose -2 now. -2 goes up to 3. So -2, and I'm going to go ahead and reflect it. And is there anything else? I could do -3, 5.5, but it's not really necessary. So at this point, I'm finished. So let's go ahead and graph it. Go ahead and put my nice parabola in there with my arrows. And there we have it. My domain is going to be the same as always, x such that x exists in the reals. And y such that my lowest value is going to be 1. So it's going to be y is greater than or equal to 1. And we're done. One thing I did want to mention is just looking at this graph. And if I go back to the previous graph for just a moment, do you notice that the coefficient a in this example is a 2? And take a look at the graph. Do you notice how thin it is? Versus the one that we just did, where we have a coefficient a as 1/2. Do you notice how it's a lot wider? The smaller that the a coefficient becomes, or meaning, the smaller the fraction becomes, the wider the parabola is going to get. And if we were to go back up to this example, and if I were to change that 2 to a 4 or to a 5, it's going to make the parabola get a little bit thinner. So it's kind of an interesting characteristic about the parabola that you can identify just by looking at the equation. All right, so that wraps up our section on graphing quadratic functions.